Let's set the context for our first project. On the screen is our final drawing that we're going to submit at the completion of this project. And as you can see, it's composed of a bunch of different views. And I want to take a few minutes to describe how they're found and their purposes. I also want to introduce you to this overall concept of BIM, how we work in this digital environment. BIM is for Building Information Modeling. I wanted to give you a quick introduction to it, not the exhaustive view that you'll get as you move through the program, but enough to familiarize yourself with the overall idea about creating a digital model and then using it to communicate all kinds of ways to all kinds of participants in the architectural project. And we'll close it up with just an introduction to the project itself. So I've created just a brief list here about the kind of drawings, and I wanted to show you some slides so you have some visual examples of what these are. Floor plans, I think we're all familiar with. A reflected ceiling is a view of similar to the floor plan, but as if you were looking in a mirror reflected view of it, looking down at the floor, seeing the ceiling. Elevations, interior, exterior, the eye level perspective looking on it at your building. Site plans set the context. What's the things that are the relationships of roads and lot lines and other architecture to our buildings. Sections, a way to cut through our architecture and reveal things, and really to zoom in some sections to create details of all kinds of elements like door and trim details. We also make structural drawings and can in BIM reveal structural details that might be hidden by other elements and outline where structural steel and other elements that hold our building up, foundation systems. Something most people wouldn't be familiar with, MEP, mechanical, electrical, plumbing drawings, indicating the heating, ventilation systems, lavatories, electrical service within the building plan. So our first examination would be the site. This is really the bigger view of our project. On the left side is the project browser that Revit uses to navigate through. It's important that you have an understanding that most of the way you move around your model is to go to these views and examine your model and modify it. So we have in the floor plans, the grander view is the site plan. On the left, the first drawing is a site plan for a small residence. This would be the kind of drawing that might be used for a submittal for a building permit. And it locates lot lines, streets, placement of residents for setbacks along those lot lines. The one on the right is more of a graphic one. I thought it was attractive, so I included it, but it helps to bring the viewer into the context of the building with relationship to roads and other, in this case it looks like a campus setting, other buildings on the campus. This is the floor plan view. The idea is that we cut through the building looking down upon it at a 4-foot level, and it tells us the relationship of rooms, placements of fixtures, locations of doors and windows, door swings, points of egress. This is an elevation view. In this case, I think it's actually the north elevation as I'm looking at the drawing. I picked this graphic depiction because I thought it was very attractive with the ghosted trees, nice use of weighting in the lines of the windows and doors, and some nice shadow detail. But this is that was a very nice drawing. Okay, so we can then take that kind of an elevation and actually cut through it at a cut plane, and now we have a section. And you'll see that on the navigation palette, this has been added. I created this section, and it added that section in Revit right over here. These aren't actually section 1, but these are some drawings that are sections that I thought were useful to describe the concept. On the left is a complete building section. You can see the stairways making access to what looks like a 4-story building. and that's a building section. And on the right is a detail section, as I've described, zooming in to show you where structural elements might be, roof conditions, the way walls, or excuse me, doors and windows might be constructed. I've included this because we discussed perspective views. Primarily, we're going to look at our models in our software, either in a perspective view where lines converge and objects recede into the background, they become smaller. But we also have this idea of orthographic projections, where all of the items within the drawing could be directly measured and be accurate with relationship to each other, so we can take scale dimensions off of it. And we obviously can work in plan and elevation with this idea of orthographic views. The isometric views, these other forms of views, really aren't as important as they might have been in a time when we were actually drawing on paper. These related to the concepts that we would use when we were trying to actually physically draw and represent three-dimensional objects on two-dimensional surfaces. Wanted to review the concept of perspective. Here we have the idea that an object in the front is larger than the object that it recedes back. It's a common visual way to help us understand three-dimensional objects on a two-dimensional plane. Now I'd like to just go over this whole idea of BIM. It's a big topic. It travels through our whole design education, and we participate in it really in all of these aspects of it. But a lot of our education will be based on maybe the first third of this circle. The fundamental idea is that we now create our building as a digital model, and we extract information. Well, we embed it with information, and then we extract information out of it to help us do everything from programming to its first stages of design, to analyzing heat and loss, to creating the construction documents, to phasing the project. And like I said, this is probably a lot to bite off in the first look at computer design, but it really needs to be underlying the thinking going forward with working with digital models. So here we have, this is just basically a diagram of an architectural design project going from the idea of conceptualizing it to actually building it. And all I've done is highlighted in red here the idea where BIM, the computer model, really plays a critical role. The idea here is to show the significance of our time spent learning and working with this tool as it relates to our involvement with projects. And this could have actually been extended all the way back into conceptual design and all the way out through construction bidding. These are shown a lot when we talk about BIM modeling. The idea is to show that with BIM modeling, and this is really kind of helping people buy into the concept of BIM, and it's actually becoming a little bit dated now, but these are kind of jokes of how we would look at representations of technical drawings and then make mistakes in the way we built them and miscommunication. So the idea that hole in the floor is created by the idea that somebody put a cloud around the kitchen to indicate that they were pulling off that detail. And the stairway on the other side is kind of the idea that the leader line and these details were actually imprinted into the floor. But that's probably the more humorous idea of miscommunications in architectural construction. More important to the idea of BIM is that our buildings are really very complex objects, and a lot goes on them, and the management of them, especially at the early phases, can pay great dividends. And in this case, we're showing a room with a lot of HVAC, plumbing, structural components, all needing to be coordinated so that they aren't bumping into each other. and that avoiding the conflict early on in the program is about cost savings and good management techniques. So that idea of things bumping into each other, this is one of the strong features of BIM, the ability to manage this idea of collision detecting. Because we're working in 3D space, it's easily, when you're making drawings, to let a pipe go through a beam thinking that one item passes under or over the other one. But when we actually start making models, it becomes very obvious that there's these ideas of collision. And these are resolved early in the process to avoid a lot of cost and lost time in the actual project. Building information modeling also opens up a whole avenue of being able to bring in sophisticated information about the componentry that we use. In this case, I'm showing you a window. The window can have all kinds of information that comes in numeric data form and also in its physical artifact. And that can be captured and used all the way through the process, from cost estimating to the ideas of heat loss and other performance issues of the window. This is just a slideshow. I've got a hyperlink to it if you wanted to see it directly, but I thought it had a lot of nice imagery to it. This is kind of the progression of CAD. We're really at the end point of this drawing right now, and we might lose touch with where we started from as far as architectural representation. But a lot of these ideas follow through. The idea that eventually we don't look at models when we go to construction documents. Many times we're looking at just flat two-dimensional drawings. So we started obviously with sketching and drawing on paper. Computers come along and allow us to do that digitally, but they don't really advance really the way we talk about our architecture. Eventually we advance to the point where our models are now three-dimensional. Our computers are powerful enough to render and construct three-dimensional forms. But those forms are still just forms. BIM modeling, this final drawing here, is now the idea that all of the information about these walls, their height, their length, their width, and even the details of how they're constructed are now really advanced and contain a rich wealth of information so that they can be used to create cost estimating, analyze surfaces for fire ratings, and the idea that they have relationships to each other. So this idea of parametric modeling. So in this case, the red wall and the purple wall are related to each other by a joint. If I move this wall, that wall will go along with it, and that'll become a little clearer as we move along. So this is a little maybe difficult to understand graphic here. I'll walk us through it. The idea that original CAD methods, we would draw the plan elevations of the building. We would decide to review it and make changes, and we would then completely reconstruct the drawing again, including making a new plan view, new elevations. CAD made it simpler because we could reuse some details, but it really wasn't a very sophisticated method of making changes. The BIM model, on the other hand, really takes it many steps ahead. The idea is you create one BIM model. If you decide to extend the wall or move the wall, the model can just parametrically update, and there's no need to make drawings of the elevations or the floor plans because they're already created for you. And this is kind of an example of that. This is a little bit of an animated drawing. So over on the right-hand side, we have a building, similar kind of project thing that we're going to do to start with a couple of doors and windows and some walls. And at the same time, the floor plan, the section plan, and the elevation are all automatically generated from this 3D model, along with a window schedule describing there's two windows, they're the same, and their dimensions. If we decide to make a modification, which might be, I'm selecting that window there right now, and you'll see it highlights in all of the views, and we make a change to move it, it updates in all of the views, and I'll just flip back and forth. The idea that we make a move and it updates in all of the views, critical to our understanding about how we're working with this model. And we can change the size of that window parametrically. That automatically updates all the way through to details on our spreadsheet. And So this is a nice little animation of a larger project, but suffice it to say, what we've looked at is we create the model, and all of the geometry of the model can be represented in two-dimensional forms for us. Much of the work that architects do to create construction documents. So, and as I've described, it's not just a physical model, it is data. Data can be how much heat loss is happening in certain areas, how much material is needed to be used, how much structural loads are on surfaces, really almost anything that we can decide to quantify about a building and the project. Further to the pleasure of using BIM modeling tools is the idea that these objects, when they're imported, they're parametric, which means that you can actually change their shapes easily and modify them to fit your needs. And you can import a whole host of other BIM objects from other vendors and sources. And I kind of discourage a little bit of this because there's the idea that we spend our time shopping for componentry instead of doing design. That's not an either or, but a lot of what we'll do in this course is take existing objects and modify them to suit our needs, allowing us to preserve the idea of an architecturally creative basis for our work. Once again, we're looking at that kind of diagram about how it goes through the whole process. It's part of that same slideshow. I thought this graphic was kind of useful. That the idea is that since everyone participates in this model, predictability changes, updates in the whole process because they're centralized around one single model. Much more efficient project management. That's a relatively sophisticated concept that we will become familiar with as you move through the program. This is just a nice animation of a model showing you how many components sit within a BIM model and how those could be deconstructed to look at even the phasing of a project. So I'll just snap through these. We start out with a foundation. This could actually started out with a site in the excavation, but these are the foundation piers. Structural steel, floor systems, starter wall systems, second floor, roof system. We add facade. We add, looks like a green roof. Finish off the roofing systems, finish off the facade systems. Add some mechanical, more facade elements. We build the site, and all of this is existing in that same model. And finally, it looks like a parking lot gets added onto the model. But anyway, this is in the PDF. It's, I think, entertaining to step through. So this is the promise of BIM. Energy analysis to make more efficient, material analysis to build more sustainable and efficient architecture. Another visualization, the idea I've mentioned of clash detection, the ability to take the model and create high quality renderings to explain the vision of the architect and designer. Energy analysis, light studies, how light falls around the architecture for shading, creating outdoor areas. Lighting analysis, how the play of light for either artificial or natural lighting and glare control. And structural analysis, output to structural engineers so they can take looks at the necessary structural components of the building. Families are a subset of Revit. I think I'll avoid covering that. We're going to do that a lot in our projects as we move forward. Once again, tons of sourcing of already made BIM components. Once they're sourced, they can be tracked through the project, really saving a lot of time during the process. Fundamental to our understanding of this model is the idea that a model can represent in 3D less information than it does in 2D. So in this case, we look at a wall. We have a wall with nothing. It looks like there's nothing inside of it. It's just a mass with a texture on the side of it and some windows inserted in it. But when we cut through it or expose it, the view can now have these enhanced details to them, showing where what the actual internal construction of our wall element is. And there's no added drawing here. This same component is now retains this extra information and displays it when you select a certain type of view. This is a graphic of wind analysis. I'm putting this in because it's important, I think, to see that this idea, and this is flow design program, but it's a plugin inside of the Revit environment that allows you to work at the site level to look at airflow through the spaces between buildings. So it's still right inside of our programming or our work environment. Here's a sun heliostat, the idea of sun analysis, still with inside of Revit. And I'll close this up by just talking about our project now. So we should be familiar with the idea that we're looking at a plan view here, or a site plan. Actually, this would be considered a site plan, mostly because we're actually seeing things that are external to the building. This is a front elevation of the building. And these two are actually perspective views of our building. And finally, this is a reference that we'll use when we get into the video. This dimensions out the idea of the sites and the building footprints on our drawing. So you can use this while you're working through the video to establish your distances on everything. So this is your start to moving into the actual construction of our first project. Good luck.